All right, we're still at Make Munich 2019, and Florian, man, last time I talked to you, you were doing something entirely different, but now you're working for Shaper. These guys, this thing is crazy. Some of you might have seen it online, but tell me, okay, what is this? What are we looking at here?
How does it look like?
I don't know. It looks like a router. You know, like two hands on it. It has a bit in there, and you can see it. It kind of mills stuff out. We've been seeing demos all day, but that's what it looks like.
So the form factor looks like a router, but somewhere there's somehow a screen, right? So it's a hybrid. It's a new category of power tools. It's a very digital power tool, internet connected, so we can ship updates to the machine, so the machine gets better and better over time. Functionality-wise, it's almost like a CNC in your hands. So you have the precision of a CNC machine in a handheld power tool.
Yeah. So basically, okay, we've got the classic bits, we've got the handles, we've got the milling spindle, but the idea is you're not just freehanding it. Well, you're sort of freehanding it, right?
Yeah. So you do the rough movement. You follow an outline on the screen. You do the rough movement as a human, and the computer, basically the robot in the machine, is correcting your position. So it's almost like an auto-correction for your hands.
Right. So it's more like a CNC router than a manual router.
But then again, a CNC machine, you somehow anticipate, you press the button and the machine is doing the job itself, right? Here you need to stay there and you need to do the manual work. So it's really a new category of power tools. Yeah.
Okay, so how does it, from the technical side, how does it work? We can see a screen, it has a camera in here somewhere.
Yep.
Well, no Shaper tape found. So it's an optical system, so it's tracking where you're moving it. But how does it achieve that?
Technically, there's one camera here, two LEDs just to bring some light to the workspace. And the camera sees what we call Shaper tape. So it's a visual marker tape. You put it down, you slap it onto your workpiece. It doesn't need to be parallel, you can just slap it down there. You scan the workpiece, the machine computes all the images together to like one local map, so the tool always knows where it is on the workpiece. And then you can place your digital file, your digital template, and then in the cutting mode you're gonna cut the part.
Yeah, so the tape itself is not to show the machine what it's actually going to cut out. Right. This is just for orientation, and the actual shapes are digital.
Right, so the tape is for orientation and for scale. So the machine needs to know how big am I, the machine, in relation to my workpiece, right? So it's position and relation, scale. And
the cool thing is you can cut things that are larger than the machine. Again, if you were using a CNC machine, you'd have this big old box, and it would take up a ton of space, but this is literally just the form factor of a router. You stow it away if you don't need it anymore.
So there's you pack it up in a sustainer. It's a box, very easy to bring to the job site or to your project. So you bring literally the tool to the workpiece and not the workpiece to the tool, and you don't have any maximum build volume. That's the beauty about it.
That is amazing. Can we actually try it out?
Yes, sure.
All right. So where do we start?
We need a workpiece which we want to work on. So in this case, it's a piece of wood. It could be a piece of plastic, HDPE, or whatever you want to mill. Then you take your Shaper tape and you literally just slap it down there. You put it there. We already have Shaper tape on here. It doesn't need to be parallel like this. You can literally place it however you want, just to get the most efficiency out of your tape. You just put it in parallel. And then you take the machine and you need to be in scan mode. You press New Scan. And you start scanning. So now you see the first time what the camera actually sees, right? And the machine indicates with like a blue color which domino of this visual marker tape was already scanned. So you move the machine and you see how more and more of those black dominoes get highlighted in blue. And the machine is so full of sensors that you actually can pick it up and you can scan also the front like this.
Oh, well, so it doesn't need to be riding on your workpiece. You can literally just move it around.
You can move it around, right? Yeah. So it really knows its position in three-dimensional space, not only 2D.
Wow.
And then you compute it. We already scanned this workpiece, so I'm canceling this one. So this is what we scanned before, and you get a local map of what you scanned. So you see.
So this is not actually a camera image. This is like the reconstruction showing you where you are. So this is actually your tool or tool position.
Yeah, exactly. So you see exactly what's below your cutter. So if you zoom out, you see the whole world, and if you zoom out once more, then you see actually an overlay of the scanned image and your actual camera what the camera actually sees.
Right.
So the interesting bit, which is confusing a lot of people, is so let's move about this above this corner. So here you see the corner. Most people would anticipate if I'm waving my hand below the cutter that I actually see it, because there must be a camera, right? But if I'm waving my hand here, I cannot see anything on the display, because this is really a reconstruction of what we scanned early on. And from there on, we are working in our mixed reality, augmented reality.
All right, so I can already see a few digital shapes on here that are not on the actual workpiece here. So I guess this is also the mode where you kind of see what you're actually going to be cutting.
So after scan mode, we go into design mode, and this is where we place our digital templates. Someone from FabLab Munich already placed a template for this kind of project we are doing, but I want to show you some stuff, how you actually place stuff. So you could go to import, and then you can either choose ShaperHub, which is our digital content platform.
Like Thingiverse.
Like Thingiverse on steroids. So that's our content platform, and you can choose to pick data from the local USB stick. So you can always use the machine without having internet connection. If you are internet connected, you can get updates. You can connect to ShaperHub. So let's go here, and you see all kinds of templates. So this could be like the body of a full-scale guitar. This could be your company logo. This could be a butterfly to close a crack in a woodworking project. It can
and these are SVG files. So anything that does like 2D design, Illustrator, for example, exports it. I guess it also reads DXF.
Right now you need to convert DXF to SVG. Yeah. So what we do is we want to stay software agnostic. So we don't want to force our users into like a proprietary file format or software. So whatever you want to use, Inkscape or Illustrator or Fusion 360 or some other open source CAD system, you can always use it. You can always somehow export it to SVG.
Right.
And then we eliminated the whole CAM step. So you never need to touch G-code or prepare a toolpath. You're just exporting a contour file, SVG, and then by color coding you can already predefine for a different user what you intend them to do. But the user always can impose on the machine. So it's still a power tool, and the user is always in control. So let's place something, maybe a butterfly here.
And you instantly get that preview of how large it is, where it actually fits on your part.
You can rotate it. Let's rotate it for 9 degrees. Let's maybe scale it a little bit and say we want it smaller, maybe like 50 millimeters wide. And you can choose your anchor points. So let's zoom into the middle, and you can place wherever you want it. So you can literally see, let's say, a crack in a wooden board which you want to close with the butterfly, and you would just by clicking, you can zoom in, and then you can place it.
Right, yeah, I hadn't thought about it, because it doesn't just care about, you know, the shape of your part, but also details and defects in your, and also pre-existing features also show up on the image.
You see knot holes, you see sketches you put on there, you can literally see everything. And now if you would go in cut mode, you see, okay, this shape was defined to be an outside cut, but even if someone color-coded it as an outside cut, you can go in there and say, oh, changed my mind, I want to do a pocket or like an inside cut. So the toolpath is instantly regenerated, so you never need to do any coding or G-code or whatever you... Yeah, what?
Is there a way to like really precisely put parts down or put shapes down?
So let's go back into design mode. We're gonna remove the shape we just dropped, and we go in precision mode. So we call it grid. So by grid, there's actually already a grid pre-marked, but I show you how to set up a grid. So you go for a new grid, you move the tool to the edge of your board, and by pressing the green button, you lower the cutter until you bump into your workpiece, physically bump into your workpiece with the cutter. You set the probe depth, and then you just follow the on-screen instructions. So you bump into the workpiece once, you probe once, and you probe a second time here. So now we basically probe the front of our workpiece, and we go to the left side and bump into it and probe another time. And now we have this grid set up.
And it's parallel and perpendicular to your workpiece. That is amazing. I mean, there's no physical probing happening. It's all based on that optical tracking, right?
Right now we did it with the cutter. If you want to get it really precise, you would use just a probe piece, like a round piece of metal, our engraved bit upside down, for example. You bump into it, you probe, and it will be so precise that you can do double-sided cuts and drill the same hole from 2 sides, and you will not see any shift or overlay or anything. Yeah.
That is pretty smart.
So now, once we have that grid, our we have a couple of opportunities. So now we always see where the tool is. So if we move, let's say here, we see this intersection of the grid is exactly 13 centimeters from this side and 14 centimeters from this side. So actually now it's a measuring device. We can see. So we can change the gridding of our grid. So let's say we want to have a grid of 5 millimeters, so it's getting more precise. And so one interesting bit here, just to show or highlight a little bit the precision, is if we disable the grid, we see up here, we see a reading with 2 digits behind the comma. So you can literally tap the...
Oh yeah, just by touching the handle, you can see that move.
You can see that move, and that's only the digits we show on the tool. So there's more in the algorithms in the background. So let's activate the grid back on and use it. So one thing I didn't show so far, I showed you could download stuff from ShapeHub. We are right now not connected. We can get stuff from the USB stick. But much more cool is the capability, what we call on-tool cut. So you don't need to have any knowledge how to use cut systems or anything. You can draw with the machine right on the tool. So let's say, for example, let's assume this tape is like a knot hole in a piece of board we would like to remove. We could use the shapes and just select the circle and then click it, and then you basically literally draw with the tool in your hand. So we just drew a circle and we could cut it right away.
All right, so instead of making a jig and then following that with a router and a follow bit, you can just draw it out. You see it, you visibly see it, and it's going to turn out exactly like that. So how would the actual cutting of that work out? Or do you want to show some more of the design?
It's a pen tool. I mean, it's literally like cut, right? So you can, with the grid tool, it suddenly snaps to the markers, and you could do whatever shape you want to do. And then in cut mode, it instantly is a usable cut path. So this is an online cut. We could say, oh no, changed our mind, we want to do a pocket. We want to get all the material out of this shape.
Yeah, the grid really helps there.
Yep, definitely. Also for aligning stuff, right? So if we import something right now, let's go in here again, and let's assume we want to place a piece of hardware, a hinge or something. It needs to be precise, right? So this would be a drawing of a hinge. So we can literally now it snaps to our grid, so it will be parallel to our workpiece. You can read off where you place it in terms of the scaling, and you can, if you want to place it freehand, you can unsnap it and move it more organically again. Okay, that's it. So let's do some cutting, I guess.
Let's cut something out.
So what we're gonna do is we're gonna use this workpiece and actually cut this piece of wood. So this will be like a bottle opener. And for this bottle opener, we need 2 holes here so that we can place a washer here. So this will be our little metal piece to open the bottle. Okay, so let's go in.
So this is the demo that if you've been running all day here.
Fab Lab Munich, they drink a lot of beer, I guess, so they want to have a lot of bottle openers around. Yeah.
Yeah. So simple. You've got a jig set up here where you clamp down a piece of wood, and you know it's a pretty simple project.
Very simple project. But if you think about it, how to do it alternatively with standard woodworking tools, it would be really hard. You would need to have the exactly sized cutters, basically, the perfect drills. I mean, with like a round shape, it's still somehow feasible. If we go for more organic shapes, you're completely lost. You need
exactly. You need a pattern for that to follow it.
So you want to try it, or?
Sure.
First run, and then.
Well, okay, yeah. Like I'm scared. Yeah. Should I be?
You shouldn't be scared. It's a very safe thing, right? There's a dust and also a safety protection, so you can literally not grab into the cutter. All the dust is being extracted right on the tool, so it's not very messy. It's not very loud, but we're gonna use some hearing protection for our ears.
Cool. Let's try it out.
As I said, we need 2 holes for this project. One deeper hole, 1 centimeter deep, and the other one is just for the washer, 1.2 millimeters deep. So.
Before we start cutting here, how are you actually controlling like speeds and feeds and all the stuff you would set, well, on another cutting tool?
Yeah, it's a very manual power tool still, so the user is still in control of everything. but you can do a couple of tricks. I can show you some of them. So spindle speed, just the rotation of the cutter is done manually. You just select it here. It's based on a very simple table. Wood is 4, usually a good speed, and then for different metals or plastics, you would turn it up or down.
Right.
Okay, so now we want to cut a pocket. We start with like a 5mm deep first pass, and then we will do a second pass to 1 centimeters. We provide what kind of line type we want to do, pocket, no offset, so we could offset to make something bigger or smaller. We're going to use that feature later. You provide the diameter of your cutter. Right now it's a 1/4 inch cutter, so it's 6.35 millimeters.
Yeah, this is standard cutter size. This is not something that's proprietary. Well, you can get them here too.
Yeah, there are no proprietary cutters, so you can put in whatever tool you want. You just provide the diameter and you can get it running. So there's a feature called set touch. So if you change cutters, you need to probe the distance between the cutter and the workpiece, right? So you just press set touch and you press this once and the tool will go down and probe itself. That's it.
Yeah.
And in speeds, you can define the speed, how fast the cutter is plunging into your material. If you have a very delicate material, you definitely want to turn that down. And you have something called auto speed, which we will look in later. There are 2 different modes of how to operate the tool, and there's one where you can definitely preset the speed.
Right.
Okay, so let's get this going. We do a first pass on this pocket now. So I'm gonna switch on the spindle, and I'm gonna plunge the cutter. And I forgot to turn on the vacuum cleaner. Now it's on. And now I'm gonna freehand the shape. It's almost like a free coloring mode. So now we go to the outside and we select from pocket to inside.
Okay, so what did we just see there? So you did 2 cuts. You did an internal roughing pass basically, right? And then you did a finish pass on the outside.
The pocket cut. Let me clean it up quickly. So first we did a pocket cut. So we were clearing out material, and then for the finish cut we did an inside cut to get this shape exactly on size. Now you see a little bit of tear out here, which is coming from an upcut bit, so the wood grain is being pulled up. So that's but you see it's a very nice crisp contour here.
Yeah. And it's softwood, so I mean that's always hard to cut. So looking at the screen here, so we've got this circle here. So this is basically the range of motion that the tool can correct for, and then the center point is where it's actually cutting, right?
So let's go into what we call air cut modes to just demonstrate this without all the noise. So now the cutter is above the material. We are not cutting, it's just a demo mode. And now we see the small dot is the absolute center of our tool. The big white circle is the corrective range. So I can basically move the tool like this, and you see how the spindle is correcting for all my mistakes. So if I'm very shaky for whatever reason, maybe I didn't drink enough coffee or something, or too much coffee, you see how the spindle is correcting all for my movements. So that's the autocorrect part.
There's quite a big range of motion there. How much is that approximately? Do you know that?
It's roughly about 30 millimeters, I believe, yeah. But it's definitely more than enough for a user, even an inexperienced user who never worked with woodworking, to do very nice cuts first time, and then you definitely have a learning curve, and you build up your skills, and you get very clean cuts. So there's one more thing, right now regarding feed speed. So right now I'm deciding if I'm stalling or if I'm going very quick or something. But I can also use auto mode to do automatic movement within my corrective range. So if I'm press and hold the green button, the tool is moving automatically. On such a simple shape, it doesn't make too much sense. But if I'm doing something very intricate, like an engraving of a letter or something, it definitely makes sense. And also, let's assume we are cutting some very intricate material, maybe plastic or something. We need a very defined speed in order to get a perfect cut without melting the material. We could predefine the speed in auto mode and then hit it exactly like it's supposed to be.
Okay, nice. Can I try it?
Definitely. Let's go for the second pass, I guess. So you do the outside first, and then you change the line type to pocket, and you clear out the rest.
All right. Between those, do I need to retract? Do I need to pull up the tool? Yeah. Okay. Well, I guess that's the red button. Then well, just try this.
So you switch on the vacuum first, just once, yeah. You're gonna power on the spindle. Yeah. And now you press the green button once. And you're gonna move the tool upwards, yeah. So it's also giving you indication on which is the better direction for cutting in order to prevent climb cutting. You can retract with the red button, and now you click on inside. 1 second, go a little bit back, yeah. And then pocket. Yep, and now you're gonna dive in. Yep. And all the little bit like lighter blue color, you just need to get away. So right now you're climb cutting. If you go the other way, it's a little easier. And we do quite a heavy pass, like it's 5 millimeters of material. It's very ambitious. Okay, now you can move over to the other circle, and you set your depth to 1.2 millimeters. Perfect. And move a little bit up. So right now it's selecting the engraving. Yeah.
Okay.
Perfect. Go in there. Yeah.
Okay. Now we get
the arrow. You could, just for the fun, you could try the auto mode if you want. Just press and hold the green button for a second. You could press and hold it and follow the button. Okay. So that's the different way. Yeah, perfect. Okay, with the red button you go up and you select again pocket mode. Yeah.
Pocket.
Do it again. I think you selected the letter. Yeah. Perfect. Go in there. Sweet. Perfect.
Okay. I have no idea how that turned out.
Okay, again, as I said, a little bit of tee out, right? So let's just remove the tee out for a second.
Well, but I gotta say that felt weird, because it felt like you're using an actual router. It felt like you're using an actual power tool, but the machine is kind of working for you. It's a weird sensation.
It's very interesting. You can literally have kids or someone working on it who never used the router, and they will get it first time. At the same time, a pro also is like, oh, that's interesting, like I'm learning something here. So we get a feedback that even people who work for decades with routers, they say they actually get a new take on how they operate a manual router after using Shaper Origin. So it's, I don't know, there's some magic to it and some strange feedback, right?
Last thing we gotta do is mount the washer, right?
So we're gonna try that, and it doesn't fit perfectly. Why doesn't it fit? Because the Fab Lab Munich guys are sneaky. They want to show off another feature of Shaper Origin, which is the offset feature. So let's assume you want to fit something. Let's say you do some intricate joinery work for a table or a chair, and something doesn't fit.
That feels wrong, doing like intricate stuff like that, doing it with a semi-automated tool. Isn't that cheating?
You call it cheating. Some people call it being efficient, or no. Like what we see is, especially with professional carpentry people, they don't have time to do that. Like no customer is paying for this kind of quality work. But with Shaper Origin, you somehow can get back to very old traditional works and interesting details, but automizing them in a way that they get more cost effective again.
And I guess it's way less manual and specialized in doing something like a Panther router that people might be familiar with.
It's more flexible, right? You can literally come up with any shape you want and just throw it onto your USB stick or send it via Shaper Hub, and you can just go for it. With a Panther router, you always need to have a template. So where's the template coming from? Again, you need a laser cutter or a CNC machine.
Bandsaw, do all the work. And yeah, with the offset, of course, if your template is too large or big, there are a few ways to do it with a Panther router. But Here, let's check it out how that works.
They do it with like a stripe of.
They have so that the follower on a Panther router is a tapered thing. So the further you move the follower in and out, you get some sort of offset. But here, it's just a touch of a button.
Thank you. You should work for our marketing. No, just kidding. So let's go back. We definitely want to make this round shape a little bit wider. So we switch back to inside, and now we do an offset of 0.1 millimeter, but negative. So we want to go to the to the outside, and we can run that quickly. That's. So now we took away 0.1 millimeters, like a fraction of an inch, and suddenly, magically, the washer fits.
Wow.
So let's try to get this fixed in here so that we can open our bottle. No pre-drilling here, I'm lazy.
Yeah, we do have the cordless drill at hand here, but whatever.
Let's see. Yeah, it works. It's softwood at the end of the day, so finally there's an advantage to this. Okay, so now we fixed this one. I think we have to do one more thing. Hopefully the machine fits here. Yeah, it should fit. So we want to drill one little hole here in order to fix like a fancy little cord to it, to our bottle opener. So let's go here and discuss one more feature which is really cool. So because Shaper Origin is a internet connected tool, we can ship updates over the air, and we do that very regularly. So every 1 to 3 months there's a new update coming. Of course there's new languages if we expand into a different region. It ships new features, and if there's a bug somewhere, we can definitely fix it, right? So with one of the last updates, we shipped something we call Helix. So as soon as you have a feature, it could be a round or a triangle or whatever shape you want to have, which is smaller or likewise big as your corrective range, you can, instead of taking passes on the material, let's say you want to cut 18 millimeters deep, instead of taking passes, maybe 5 millimeters, 10 millimeters, 15 millimeters, 18 millimeters.
And then manually readjusting the depth every time.
You just go for 80 millimeters right away, and then you're gonna cut this hole. So you activate Helix, and it will spiral down into the material. Now, sadly, this shape is a little bit too small, so you don't see the spiraling. So I'm trying something. I'm not sure if it works. I'm doing a negative offset of maybe 0.5 millimeters. So we're gonna artificially make it bigger and to see more of the visual. So because now I'm activating the vacuum, I'm gonna turn on the spindle, and then I just hold the tool, fire it off, and you see what happens next.
Let's try it. So basically, drill press included with an arbitrarily sized drill bit.
And that's funny, right? Like, that's the perfect description of what we just did. And interesting enough, to a lot of especially professional users, that's mind-blowing. They say like, oh, that's really cool.
You don't need to change the bit. It's just...
You don't need to change the bit, and you can get perfect fit for whatever fitting you wanna place. So let's look at stuff like this. So hardware is a really big thing in carpentry, in Finnish carpentry, if you want to build furniture or cabinets. So you need to fit all those things, and you can just get the data from the vendor, put it on there, and then place it, right? And
if it doesn't fit, you use the offset.
And a lot of those fittings are based on round shapes, so you could literally draw it with the machine and get it cut right away.
Okay, simple piece, but man, I gotta say that the feeling you get when using the machine is like, it's so strange, but it's kind of satisfying. It's
it was a very simple project, right? You can go as big as you want. You can go much more intricate. The interesting thing is how well the machine scales, from engraving something as the size of a coin to like a crazy big inlay work on a flooring project. Everything is possible with the same machine.
I mean, basically, of course, you can say this is just something that you use 2 Forstner bits with and just go in there and it's done. But it's a demo.
Yeah.
It's a demo of how the machine's features work. Yeah. So who are you selling the Shaper Origin to? Who's the audience for this?
The main audience definitely right now is professional woodworkers. So
I want one too. I'm not a professional woodworker, but I want one.
that's what we are seeing at events like this. Like there's a huge interest from the Fab Lab community, from maker spaces, from creative agencies, from industry even. There's a huge variety of potential customers. It's still early for the product. It's such a new concept and kind of hybrid in power tools between like a highly automated tool and a handheld power tool. We're really excited to see where this is going.
Yeah, so the question of course still stands is how much is it going to cost and when or how can people buy it? Because this was a Kickstarter originally, right?
No, like it's funny. Everyone thinks it was a Kickstarter. It has never been a Kickstarter. It was like a private pre-order on our website. Very successful almost 2 years ago, I think.
So like a Kickstarter, but...
Yeah, like a Kickstarter, yeah. We shipped the first batch of pre-orders, we shipped the second batch, and now we're in full sales mode for the US and Canada. So in the US and Canada, it's readily available. In
how much?
It's $2,499 in the US. Yeah,
okay. So that's
day delivery or something like this.
That's quite a bit more than a manual router, but if you compare it to the full-size CNC that can do that scales, it's still there.
Depending on your use case, I think it's how you say it's not cheap. Like it's a deal. It's
you get value out of it, I guess.
Yeah, right.
And Europe, any plans for these getting to us? Anything you can disclose at this point?
We are definitely, the whole team is very committed in bringing it to the market. The merger with TTS now is very exciting for us. There's lots of resources for us ready to somehow scale up and get this going. We are very committed to the European audience. Like we see so many comments from all around the globe, especially Europe. Where is this tool? When can we get it? Like, we ask for your patience. It's going to come. We are very committed to get it here as soon as possible.
All right. A very cool tool, Florian. Thank you for your time. And I'm looking forward to what you guys come up with next.
Yep. Right. Thank you.